Okay, we have two equations and we'd like to plot them. The first one we're going to plot is y equals 3x. So in order to plot this graph, we just set up a little table here of x and y, and we say what is the value of y when x equals minus 1? Well, we plug in minus 1 into this equation. So 3 times minus 1 would give us the answer minus 3. That gives us the first point on our graph. We go minus 1 along on x, and we go down minus 3. So we go first here, then 1, 2, 3. So it gives us the point minus 1, minus 3 on our graph. Then when x equals 0, y is also going to equal 0. So it gives us the second point on our graph. When x equals 1, well, y will be 3 times 1, which will be 3. So x is 1 and y is 1, 2, 3. 1 along, so the x is how we're going along on the horizontal axis, and y is how high we go on the vertical axis. When x equals 2, y is going to be 3 times 2, which is going to give us the value 6. So when x is 2, we're going to have the value 6. So here we have our line representing the equation y equals 3. And we can join those points together. And it's always smart to label your graph. Y equals 3x. We can see that this graph goes, or this straight line goes through the origin. The origin is the point 0, 0. So that tells us directly that any graph with a straight line that goes through the origin is proportional. It doesn't matter how many times we increase x, the value of y will be an exact ratio, you can say that. So if x is 15, then y is going to be 3 times 15, it's going to be 45. Y is always going to be exactly 3 times larger than x. Let's have a look at this graph then and say, right, let's work out the gradient. And what does the gradient mean? Well, we've talked about it being rise over run. What does that mean? Well, it actually means that we actually look at how many do we go up the rise for how many we go along, which is what we call the run. So the gradient of this graph is going to be rise over run. And if we look where I put the red lines now, we went up 3 and across 1. So the gradient of this graph is going to be 3. So that's what we can see directly from the graph, and we work it out by either thinking the amount that we go up in the y-axis divided by the amount we go along in the x-axis. And it wouldn't have mattered here if I had decided to take a different point. Let's say that I would go from this point here and go along 3. I would still count how many I would go up, and I would go up 1, 2, 3, 4, 5, 6. So I haven't drawn this one very well, so we'll take this one out because I haven't drawn my graph properly. So let's take a slightly easier one where it's more in line with the coordinates. Let's say that we take from x is 0 again, we go along 2, and then we go up 2, 3, 4, 5, and we go up here to this point here. So for going along 2, we are going up 6 points. So our rise over run, our gradient, would be 6 up. For 2 we go along, so we'd still get the gradient of 3. So the gradient of this graph is 3, which is what we would expect, because all straight line equations have the form y equals mx plus c. We can see that there is no intercept, so c in this particular case would be 0. And we would expect the gradient to have the value of 3 because we know that it's going to be the rise over run. So that's the first line that we've drawn. Let's look at the plotting the green graph. When x is minus 1, y is going to be 1 minus 1, which is going to give us minus minus 1, which is going to be y plus 1, which is going to give us 2. So when x is minus 1, y is going to be 1 minus minus 1, giving us 2. When x is 0, y will be 1. When x is 1, y will be 0. 1 minus 1 is 0. And when x is 2, y will be 1 minus 2, which will be minus 1. So now we have the coordinates for the graph y equals 1 minus x, so we have to plot it. At the point x equals minus 1, y is 2. At the point x equals 0, y is 1. At the point x equals 1, y is 0. And at the point x equals 2, going 2 along, y equals minus 1. So here we have the coordinates of our green graph, and we can draw a line through there to give us our straight line. And we can look and investigate this straight line equation in the same way that we investigated the other equation. We can see from the graph that the intercept point is at plus 1. So if we look at our graph of the form y equals mx plus c, we can see directly that for the green line, c is going to equal plus 1. It's exactly where it cuts the y-axis. At the point x equals 0, you just read off from the graph that c equals plus 1, wherever the graph cuts the y-axis. Then we need the gradient. Well, we can take the gradient from a good place to take it here, I think, would be to take it from the point x equals 1 and go back 2 places. We can see that the rise is 2 and the breadth is 2, but the line is going in a negative direction. So whenever it's leaning backwards like this, the slope or the gradient is always going to be negative. So let's look at the equation here then. So y is, the gradient is going to be the rise over run. That's going to be minus 2 divided by 2x, which is going to be minus x plus 1, which is what we plotted, because we plotted y equals 1 minus x, and those two equations are the same thing. Let's look at a little bit more, well, why does the gradient get negative in this curve? Well, we actually have to then think of the coordinates of this graph. The coordinates of this point up here was that x was minus 2 and y was plus 2. No, sorry. The coordinates were of this particular point is that x is minus 1 and y is 2. And that's the coordinates of this point here. The other point that we took our gradient from was down here, and that is at the point x equals 1 and y equals 0. So the top point here is our x2, y2, and the bottom point here is our x1, y1. And we know that the gradient of any straight line is the same as y2 minus y1, the difference in the y-axis divided by the difference in the x-axis. In this particular case, y2 is 2 minus 0. x2 is minus 1, and x1 is 0, is 1. So we get 2 divided by minus 2. Minus 1, giving us minus 2, giving us a negative gradient. So every straight line that goes backwards will always have a negative gradient. So this is another basic introduction to equations of a straight line. We have defined the word origin, the point 0, 0. We've defined the word proportional. When a straight line goes through the origin, the graph is proportional. If it doesn't go through the origin, it isn't proportional. The axis, the y-axis, is always the vertical axis. The x-axis is always the horizontal axis. Coordinates, that's how we represent the number that we go along, the x value, which is the first value in our coordinates, and the y value, how many we go up or down, is the second number in our coordinates. The gradient we know as it being rise over run, and the intercept is the point where the straight line cuts the y-axis at the point x equals 0. So all of these definitions are important to remember as well for graphs.